Welcome back to Chapter 2. Today we're going to be looking at Section 7, which is solving equations in one variable. Now, this is something that you've been doing since Algebra 1. You've been solving equations with one variable like crazy. So we're not going to focus on just like linear systems or even so much or linear equations or even so much quadratic equations. We're going to be looking more at the rational equations. Because they're the ones that are a little bit tougher to deal with. And then they end up involving some of those other ones. So our learning targets, we can use algebraic and or graphical methods to solve rational equations. We can use a graph to decide if solutions to rational equations are extraneous. And what an extraneous solution is it's one that comes up algebraically, but it doesn't actually fit. And we'll see those in just a minute. And then solve applications involving rational equations. So, solving rational equations, something like x plus 3 over x equals 4. Couple ways of going about looking at this is one, you could write it with a common denominator, or the other way to do this is you multiply everything in the equation by the common denominator. That would be everything on both sides. So here we have x times x is x squared. X times 3 over x is just 3, and then equals 4x. Now we have a quadratic. We can subtract it over, minus 4x plus 3 equals 0, and then factor. Most of these will probably be factorable. Like, it's not about the solving the quadratic or the polynomial at this point. It's getting it to be here. So we'll have x minus 3 and x minus 1 equals 0, because negative 3 times negative 1 is 3. Negative 3 plus negative 1 is negative 4. And this means that x could equal 3 or 1. So now what's important here is that we need to plug these back into the original equation. What happens when we multiply by that x is we add an extra root, possibly. Sometimes we do, sometimes we don't. But it is important to plug it back in. So if we plugged in 3, we have 3 plus 3 over 3 equals 4. So that's 3 plus 1 equals 4. That checks out. If we plug in 1, we have 1 plus 3 over 1 equals 4. So 1 plus 3 equals 4. So that one checks out. So in this case, it does happen to be both of them, but that will not always be the case. So let's try another one here. We have x plus 1 over x minus 4 equals 0. So again, multiply by that common denominator, x minus 4. So when we multiply it to the x, we have to distribute. So we get x squared minus 4x, and then plus 1 over the x minus 4 cancels, so we get plus 1 equals 0. And so in this case, like, we're not going to be able to factor it, but we can use quadratic formula. So x will equal negative b, so that's 4 plus or minus the square root of b squared, minus 4 times a times c, which is 1 times 1, all over 2a. So we have x equals 4 plus or minus root 12 over 2. 4 plus or minus root 12. 12 is 4 times 3, so this is 2 root 3 over 2. And then we can reduce. When we reduce, we have to make sure we do both of them. So this will be 2 plus or minus root 3. And so when we plug this in, we could figure out what those are as decimals to make sure that it works. 2 plus root 3 is going to be about 3.732. And so we can plug that in. So we have 3.732 plus 1 over 3.732 minus 4 equals essentially 0. I mean, what in the calculator it says 6.567 blah blah blah, then e to the negative 4. So that's going to be 0.00065. So that's basically 0. We rounded the root, so it's not going to be perfect. And then 2 minus root 3 is going to be 0.2679, so let's go 0.268. So we can go 0.268 plus 1 over 0.268 minus 4, those are in parentheses by the way, equals 4.7 blah blah times 10 to the negative 5. So both of these end up working out when we plug it into the original equation. Now how about a bigger one? This one, we have 2x over 1 minus, or x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. So, same thing, we need to multiply by the common denominator. Now, if we factored this big one here, we get x minus 1, x minus 3, which, remarkably enough, is actually the same thing as we had in the first equation. So notice they're the same as these guys, so we don't need any extra factors really. We're just going to multiply everything by x minus 1 times x minus 3. So in the first one, the x minus 1 will cancel, so we have 2x times x minus 3. It's 2x squared minus 6x. Plus, in the second one, the x minus 3 cancels, so we have 1 times x minus 1, which is x minus 1. Then equals, in that one, both of them cancel, so we just have 2. No fractions. So now, 2x squared, negative 6x plus x is minus 5x. Negative 1, subtract the 2 over, we get minus 3, equals 0. We should be able to factor this one. This will be a 2x and an x. Let's see, negative 3, that could be a negative 3 and a positive 1. 2 times negative 3 is negative 6. 1 times x is 1. Negative 6 plus 1 is negative 5. So we get x could equal negative 1/2 or 3. Now, yes, we do actually have to plug these in because weird stuff can happen here. So if we plug in 3, we'll have 6 over 2 plus 1 over 3 minus 3 is 0. Think that's going to cause a problem? I think that's going to cause a problem. So 3 is going to be one of those extraneous solutions. And if you look on the graph, which I didn't put the graph on here for whatever reason, you'll actually see that 3, like x equals 3, does not make sense in this problem to be a root. Like it probably doesn't even exist there. Well, it doesn't because there's an asymptote. All right, well, let's plug in negative 1/2. That should work, but it's good to plug it in just in case. So we have negative 1/2 times 2 is negative 1 over negative 1/2 minus 1 is negative 3/2 plus 1 over negative 1/2 minus 3. 3 is 6/2, that's negative 7/2 equals 2 over negative 1/2 squared is 1/4 plus 2 plus 3. So we can simplify our fractions. Remember, we can flip and multiply. Negative 1 over negative 3/2 is going to be 2/3. This will be plus 2/7 equals 2 over, so that's 5 and 1/4, so that'd be 21/4. So 2 over 21/4, we could flip and multiply to get 8 over 21. Well, common denominator of 21, so we can multiply this one by 7 over 7, multiply this one by 3 over 3. So we get 14 over 21 plus 6 over 21 equals 8 over 21. Oh, there's my problem. I'm like, wait a second. That's a plus sign. I put it as a minus sign. So that would be plus, which makes this minus, which makes that a minus 6, which 14 minus 6 is in fact 8 over 21. So that works out. One of these should definitely work, and when they don't, a lot of times it's something like that happens. So we get x equals negative 1/2 in this case. And again, if you had the graph, you can check it with the graph too, because it's either going to go through negative 1/2 or it's not. Like it's not going to be like, oh, it's really close and went through like negative 0.503. It will or it won't. Like it's an obvious thing. Another one, very similar here. Uh, in this case, notice we could factor out next here to get x times x plus 2. That's the same thing. So we can we can multiply by x times x plus 2. So we distribute. The first one, the x cancels, so we have x plus 2 times x minus 3, which is x squared minus x minus 6. The second one, the x plus 2 cancels, so we have x times 3, so plus 3x. And this one, the whole denominator cancels, so we have plus 6 equals 0. We can simplify. We have x squared plus 2x. The minus 6 plus 6 goes away, equals 0. So we have x times x plus 2 equals 0, which means x could equal 0 or negative 2. Both of these, when we plug them in, we get to 0 or to the negative 2, or either of them in this case, we're going to get division by 0. So in this case, both of these don't work, and so there's no solution. It could go like that. So if you graphed this, it's going to always be positive or always be negative, but it won't, or at the asymptotes it'll switch, but there won't be a 0 in this entire graph. Let's look at an application really quick. So this is a mixture problem. This one happens to be an acid mixture problem, but it doesn't have to be acid. It could be anything. And so what the mixture is, like we want something that's 75% acid, that means the total acid divided by the total mixture will equal 0.75. So we need to figure out how much acid we need. So we're adding pure acid, must be added to 50 milliliters of a 35% acid solution to produce a mixture that is 75% acid. So our total mixture, our first mixture, we have 50 milliliters, so that's how much is there. It's 35% acid. So how much acid is that in 50 milliliters? Well, that's going to be 0.35 times 50. That's how much acid is in that 50 milliliters. And then we're going to be adding stuff to it. We're adding pure acid, so plus, since it's pure acid, that's 100%. So I'm just going to say 1 times x. We don't know how much of it we're adding, but that's also increasing the total. So the x will be down there as well, and that will equal 0.75. So now we can do some calculations here. 0.35 times 50 is going to be 17.5. So we have 17.5 plus 1 times x is x over 50 plus x equals 0.75. We have a rational equation. We're going to multiply by the denominator to both sides. 50 plus x. So we'll end up with 17.5 plus x equals 0.75 times 50 plus x. So 0.75 times 50 is 37.5 plus 0.75x. We can subtract. So if we subtract the 0.75 over, x minus 0.75x is 0.25x equals, subtract the 17.5 over, we get 20. And now we can divide by 0.25, divide by 0.25. So we get x equals 80 milliliters. So we would need to add 80 milliliters of a 100% acid solution to bring the 50 milliliters of the 35% up to a 75%. So anytime you're dealing with these application problems, you want to look at a formula. A lot of times the formula is going to be like the area of a rectangle or something like that, like something that you're more familiar with. I picked the mixture problem because this, setting that up, is something that people struggle with a bit. So you'll have some application problems, but again, the idea, you're going to multiply everything by the common denominator, solve it now that you don't have any fractions, and then be sure to check for those extraneous solutions. You can look at the graph of it, you can plug it in, but make sure that you're doing it to the original equation to see, does that solution make sense? So with that, I will see you in class next time. But until then, keep working problems, keep asking questions, and as always, happy mathing.